Let's talk more about ionic solids. Again, when you write the formula for an ionic solid, it's always the lowest ratio of what you would find in the crystal. These are very, very giant crystal structures held together with ionic bonding. And remember, ionic bonding, this is where you have your negatives next to your positives. And you have that attractive force, that electrostatic attraction. And when it does pack together, the positives do stay away from the positives and the negatives do stay away from the negatives, and we have these unit cells. Ionic solids have high melting points and high boiling points, and how high the melting point is depends on the ions. And we talked about this when we talked about crystal lattice structure. So the most important thing to look at is the charge. So if you have ions that have a high charge, they tend to have a higher melting point when compared to something that just has a charge of a +1 and a -1. And that's what we see right here with sodium chloride. So sodium chloride, here is our negatives, here's our positives. And if we look at magnesium oxide, these are all -2 and a +2. And so because of that, if you're to go to melt this ionic solid, you're going to have extremely high amount of energy or a high melting point in order to break those ionic bonds. So you can melt some ionic solids, but generally they cannot be melted in the laboratory because their melting points are much higher than something that's covalently bonded. We can also look at the sizes of the ions. So this is the second thing that you would look at to determine which has a higher or lower melting point. The smaller the ions, the closer they can get together, so therefore the stronger the attraction. You have sodium chloride having a higher melting point and boiling point as compared to rubidium iodide, and that's because it is smaller. So we have our sodium and our chlorine, and then over here we have our rubidium and our iodine, and you can see that because this one is smaller, then it's going to have a higher boiling point and melting point for that matter. Ionic solids are brittle. If you apply a force and you jostle everything so the negatives are next to the negatives and the positives are next to the positives, they will repel each other. So ionic crystals, they are very brittle because of this. They tend to be soluble in water because they are ionic, they have a charge, and water is polar and has a charge. The charges on the water molecules, they will be attracted to the cations and the anions of the ionic crystal, and so they will be able to be pulled apart and dissolved. They tend to be insoluble in organic solvents, and this is because organic solvents tend to have lots of carbon and hydrogen chains, and so they tend to be nonpolar. They're nonpolar and just have dispersion forces, and if you put these ionic bonds in there, the dispersion forces are not strong enough to pull apart that crystal. Ionic solids have a low volatility, so that means they do not easily go from a solid to a gas, or even if you had in the liquid phase going to a gas, the ionic bond is going to be pretty strong to keep it in that phase. And also the electrical behavior of ionic solids, you should know that they don't conduct as a solid, but they do conduct if you dissolve them or if you melt them down into a molten ionic solid.